Picture this. You're sitting in the Cambridge IGCSE 0478 Computer Science exam hall. The clock is relentlessly ticking down, those grade boundaries are brutally tight, and you're staring at a 4-mark question asking you to justify the use of HTTPS over HTTP for a school portal. You scribble down your answer. You actually feel pretty confident. But here's the harsh reality. What you don't realize is that you just lost every single mark.
Take a look at this incredibly common answer. HTTPS is a secure internet thing that stops hackers from reading the school website. This is the ultimate, I kinda know this, but my mind is totally blank, exam response. And to a normal person on the street, this feels completely true. It sounds right. But in the strict reality of the Cambridge 0478 mark scheme, this answer scores a flat 0. Nothing. Nada. Why? Because the examiner isn't checking if you vaguely understand what the internet is, they are stress testing your mastery of precise computer science terminology. They want to see if you can apply a theoretical mechanism to a specific scenario. When you use vague filler like secure internet thing or stops hackers, you're just showing simple recognition. And simple recognition simply does not survive this exam.
Look at the absolute contrast here. On one side, we have that vague, secure internet thing. But compare that to the top band precision on the other side. Encrypted protocol for transmitting web data. This is exactly where ordinary everyday revision falls apart. Students will literally spend hours flipping flashcards without realizing they're completely confusing a protocol with a service. A service is what the user actually experiences. It's like the beautifully plated meal delivered to your table at a fancy restaurant. But a protocol, that's the strict mathematical and logical rule set governing the data transmission. It's the rigorous hygiene and safety protocols happening behind closed doors in the kitchen. If you just memorize the menu without understanding how the kitchen operates, you heavily cap your grade. That top-band answer uses power words: encrypted, protocol, transmitting. That instantly signals to the examiner that you understand the actual mechanics, not just the marketing fluff. So, let's look at the absolute graveyard of lost marks for this syllabus. These are the classic 0478 errors. Vague wording, as we just saw, is the #1 killer. It happens when that exam panic sets in and your brain just screams, "The internet is safe!" Then we have confusing a protocol with a service, or honestly, confusing memory with storage, or a compiler with an interpreter. Next up is ignoring the specific scenario. If the exam asks about an automated robot and you write a generic textbook answer about a smartphone, you're going to lose marks. And finally, missing process steps. This is when you name drop a method like encryption without actually explaining how it scrambles the data. Make these mistakes and you are literally destroying your grade boundaries.
Now, in just a second, I am going to show you the exact hidden examiner clue that flips an answer from 0 to full marks. But first, you need the framework that makes that clue completely obvious. Because once you lock this structure into your brain, you will absolutely never write a vague, panic-driven answer again.
Here is your foolproof framework. The source material shows us that a highly reliable memory structure for comparing HTTP and HTTPS relies on exactly 4 prompts. Number 1, what is it? Number 2, how does it work? Number 3, where is it used? And number 4, why is it better? If your exam answer doesn't hit these 4 distinct beats, it's incomplete. And hey, this isn't just about HTTP. This specific sequence forces you to move from basic recognition to deep understanding and finally to actual application. It literally wires your brain to identify the digital problem, the data involved, the process, and the practical real-world consequence.
Let's put that exact framework into action by contrasting HTTP and HTTPS. Under what is it? Well, HTTP is a protocol, while HTTPS is a secure protocol. Pretty straightforward, right? But look at how it works. HTTP uses plain text transfer. If that gets intercepted, anyone can read it like an open postcard. HTTPS, however, uses encrypted transfer. Where is it used? Well, HTTP might be perfectly fine for generic read-only web pages where absolutely zero user data is collected. But HTTPS, that is mandatory for logins, banking, and secure portals. Finally, why is it better? This is actually where a lot of students stumble. HTTP technically has a slight advantage in faster loading because there's no heavy encryption overhead slowing the process down. But HTTPS is infinitely better for sensitive tasks because it ensures data integrity and confidentiality. By separating these nearby concepts mentally, you completely avoid the trap of writing everything you know in one panicked, jumbled paragraph. You give the examiner exactly what they want, clearly categorized. So the crucial point here is application. It's time to pause and predict. I want you to mentally write your own answer to this exact challenge right now. A retail bank is upgrading its customer portal. Justify the use of HTTPS over HTTP. Keep those 4 prompts in mind. What is it? How does it work? Where is it used? Why is it better? Seriously, take 3 seconds right now and mentally draft your first sentence. Got it? Okay, if your mental answer just said something like, it's secure and stops hackers from stealing money, you have completely failed the context. Generic responses will bomb the scenario. Let's see what a top-band response actually looks like.
Here is your perfect examiner-style correction. Read this carefully. HTTPS uses TLS/SSL encryption to ensure customer financial data remains confidential during transmission to the bank's web server. Look at how heavily anchored this is to the specific scenario. It doesn't just say data, it explicitly says customer financial data. It doesn't just say it's safe, it says confidential during transmission to the bank's web server. It names the exact mechanism, TLS/SSL encryption. This answer leaves absolutely zero doubt in the examiner's mind that you deeply understand both the underlying computer science and the real-world banking scenario they gave you.
Which brings us to that massive examiner clue I promised you earlier. Notice the massive shift from a vague effect, it stops hackers, to a precise, contextualized consequence, it ensures data confidentiality for financial transactions. The absolute biggest clue is specificity to the scenario. Examiners in the 0478 syllabus are explicitly hunting for you to tie the technical consequence back to the exact user, system, or organization mentioned in the prompt. Think of it this way. If the words you just wrote could apply equally well to a banking portal and a blog about cute cats, your answer is way too generic. You literally have to anchor it to the reality of the question.
Now, knowing all this theory is one thing, but actually retaining it under intense exam pressure, that requires a very specific approach. To guarantee exam adaptability, you need exactly 3 passes in your revision cycle. Let's break down this 3-pass revision cycle. Pass 1 is your rock-solid foundation. Secure those key definitions and contrasts. You need to know the precise difference between a protocol and a service, or memory and storage. Pass 2. Rehearse worked explanations and processes. This means practicing the exact step-by-step sequence of how TLS encryption actually handshakes and secures data. You should be rehearsing it out loud until another learner could easily follow it. But Pass 3, that is where the magic happens. Change the scenario to force adaptability. This layered style is absolutely critical, because in computer science, the high-mark questions almost always combine raw theory with applied reasoning.
This brings us to a fascinating concept from our source material, contextual transfer. Real-world transfer is everything. The exact same data transmission patterns you learn for a basic website are going to appear in smartphones, industrial control, robotics, and retail systems. Examiners are testing your transferability. If the exam suddenly makes the context an embedded system in a self-driving car communicating with a server, your answer has to stay inside that specific digital scenario. You take the exact same theoretical mechanism, like encrypted protocols, and you wrap it entirely in the vocabulary of a car's data management.
So before your pen even touches the paper in the exam hall, you need to hit this checkpoint, diagnose the demand. The source notes warn us time and time again that students lose massive marks by just writing everything they know without any actual direction. You have to stop and ask, what exactly is this specific task testing? Are they asking for the causes of a security breach, the effects of using HTTPS instead of HTTPS, the advantages of a specific protocol, or are they asking for a design evaluation of a network? If they ask for an evaluation and you just write a description, you get 0. But once you diagnose the demand correctly, you can align your full prompt framework perfectly with the mark scheme.
But right here is where we hit a massive wall. What happens when the exam throws a total curveball? Imagine they combine HTTPS with a malware and social engineering scenario. What if the user is on a perfectly secure, locked-down HTTPS banking site, but their physical device is compromised by a keylogger? Or what if they've been socially engineered via a highly targeted phishing email? This is exactly where our single-topic framework hits its limit. The examiner is now testing multi-topic intersections, and if your memory structure is only built for isolated standalone facts, you are going to freeze.
To survive those high-level, multi-topic synthesis questions, you have to rebuild your knowledge stronger and map out these complex intersections. We cover exactly how to connect these separate syllabus nodes in our next explainer. It is an absolute mandatory must-watch to ensure you don't drop those final, crucial grades when the exam gets complicated.
So, ask yourself, is your current memory structure truly ready to survive the brutal pressure of the exam hall? Don't leave it to chance. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. And click the explainer on your screen right now to master the 0478 last 7 days revision map. I'll see you there.